Hi, my name is Amber Zhang, and today I'll be presenting on the virtual lab number 1 infrared spectroscopy identification of an unknown compound. So, a brief background was that the scenario for the experiment was that the Ohio Health Department encouraged all citizens to bring unused and expired medicine to the police department, and then the Ohio Department of Health sorted them into groups of 8. So, the one of the groups of 8 that I was assigned was group number 4, and as you can see, these are the 3 compounds in group number 4, and then there was an IR spectroscopy sheet assigned as well. So on this IR spectroscopy sheet, there is a peak at 2,961.91, and as you if we go to our spectroscopy sheet, that would be around 3,000. So that would be right here if you look at my cursor, and then because that's at 3,000, that means there would be an O bonded to an H, and that would be a carboxylic acid, an oxygen bonded to a hydrogen, and so then we go back, and the next peak would be at 1,701.04. So if we go to our IR spectroscopy sheet, if you follow my cursor again, it would be at the 1,710, which would be a carbon double bonded to an oxygen, and it could be an aldehyde, ketone, or a carboxylic acid. So because of the peak beforehand was at the around 3,000, and it says it's a carboxylic acid, that means it would indicate that this would be a carboxylic acid. So then we go to our IR spectroscopy graph again, and then we would look and see that the rest of the peaks, they wouldn't be able to identify the compound as well as the 2 before. So these 2 are the most important. The left one would be around 3,000 again, which that would be a oxygen bonded to a hydrogen, it would be a carboxylic acid. And then the next one would be at 1,710, carbon double bonded to an oxygen. So keeping these in mind, we're going to go back to the we're going to go back to the group 4 compounds and say that this would correspond to adipic acid, because you see that you see that hydroxyl group on the end, and then it's double bonded. There's a carbon double bonded to an oxygen on both ends. So that this would correlate to our IR spectroscopy. So in order to the benzylamine would not correlate to the IR spectroscopy because there's nothing on our IR spectroscopy sheet that indicates that there would be an aromatic benzene ring. So if you go to our IR spectroscopy sheet, for it to be aromatic, it would be around 1,600 on our sheet, and we don't really have any strong peak there. So then we would go to we would go down to the cyclohexanediol, and then we would there's no carbon double bonded to an oxygen, and we have that very strong peak at 1,700 around there. So we would need that to be present. So a quick synopsis of how the IR spectroscopy experimental steps would go is that you would first get 2 sodium chloride plates, and then you would add the sample in the middle of the plate with a glass Pasteur pipette, and then after you add it, you would add the other plate on top and sandwich them together. Make sure nothing's leaking out the sides so it doesn't get into the IR spectrometer. And on the IR spectrometer, when you lift the lid, there's a place where you can slide your sample in. You would slide it in, and then you would close the IR spectrometer, and then you would go onto the software you're using, and you would collect background spectrum, so then you could have an accurate reading of your sample. And that is all.